are getting inundated.
This meeting is being recorded.
Hello, Sarma sir, namaskar.
हाँ जी पटेल जी नमस्कार, कैसे हो?
So should we start, sir?
या if everybody जिन्होंने ज्वाइन करना आ गए हैं तो स्टार्ट कर ली.
Yeah, ready, sir. So I can just confirm.
I would request the IT team to share the screen before we start the presentation. Namaskar, a very good afternoon, distinguished guest, resource speaker, esteemed participants, ladies and gentlemen. Wishing you a very happy and prosperous new year. My name is Kalpana for Tunneling Association of India, TAI. On behalf of TAI, we extend a hearty welcome and sincere gratitude to today's resource speaker, Dr. Harald Wagner, Senior Vice President TI, former DG Border Road Organization, former Engineer-in-Chief MOD and Principal Advisor CVIP, Lieutenant General Suresh Sharma, PVSM AVSM, Vice President TI and Honorable Chairman Himachal Pradesh Electricity Regulatory Commission, Shri D.K. Sharma, Secretary General Shri Aditya Kumar Dinkar, Treasurer Dr. G.B. Patel, esteemed guests and other dignitaries. We convey our sincere thanks to all the professionals for their time and presence for today's virtual training session on risk and control of urban flooding by tunnels, organized jointly by Tunneling Association of India and Center of Excellence for Tunnel Studies. Now, may I now invite Senior Vice President TI, former DG Border Road Organization, former Engineer-in-Chief MOD and Principal Advisor CBIP, Lieutenant General Suresh Sharma, PVSM AVSM for the welcome address and opening remarks. Over to you, sir.
Thank you, Kalpana. Okay, good afternoon, ladies and gentlemen. This is our first session in the year 2020. So let's start with a prayer and a hope that at least now that 2020 is gone, 2021 is gone, let's hope that 2022 brings some cheer, some relief from this COVID menace. But till then, now we know that we have a new threat of Omicron, but till the situation normalizes, our request to everybody is that stay indoors as much as possible, take all precautions, wear your mask, avoid going to public areas as much as you can, and observe all precautions and protocols which are being issued by the Government of India and others, medical authorities, from time to time. Okay, now coming to the short introductions. We know that the Tunneling Association of India is under the overall umbrella of CVIP. It's joined the International Tunneling Association in the year 1976. As on today, we have more than 600 members. And you are aware that we deal with all matters dealing with the tunnels and underground space. It's a single platform which connects the academia, the practitioners, the designers, the consultants, the contractors, the building material suppliers, equipment suppliers, and others under one umbrella. Sorry, there is some noise. We try and connect everybody together and also share a common link so that we can share knowledge and impart some training and cross-cultural or cross-functional aspects. We are the official link with the ITA. As and when the WTC, that is World Tunnel Congress, is allotted to India, we are the official host. And we are supposed to conduct the Tunneling Asia once in 2 years. It hasn't happened the previous year because of the pandemic. Hopefully, sometime in the middle of this year or towards the end of this year, we shall host one Tunneling Asia along with the Tunneling Awards. One of our primary concerns remains the safety. And it's our abundant duty that we bring up our new generations, and that's why we have the Young Members Association also going along, which is a very, very successful venture where all tunneling professionals less than 35 years of age have joined in, and today their numbers are increasing day by day, and their activities are increasing day by day. We very recently formed a new committee also. I think most of you are aware. Along with us is the CETS, that is the Center for Excellence in Tunnels, from a sister organization called the NHTCL. Aims are same. We have a common platform. They are also dedicated towards the thought leadership, strategic advice, and the problem solving inputs. Both agencies are collaborating to see that the tunneling efforts in India are efficient and safe. Now, coming to the speaker for the day, I think nobody needs an introduction, but since it is a new year, so let me, and some of you may be new, so let me very briefly introduce Dr. Wagner. He's a known face in the world of tunneling. Okay. He's done so much. He's been associated in this activity for more than 4 decades. To say a few things, he's a licensed master builder, he's a government counselor, he's a chartered expert at court, he's a consultant at the World Bank for more than 15 years, he's an international consultant for underground structures. He's been dealing with tunnel design, construction, and consultancy. He's been a professor, assistant professor in the University of Graz in Austria. He is a vice president in the ITA, and also he's been an expert member on the executive council of the ITA. These are some of his few qualifications and experiences, but what is more important to note is his readiness, his enthusiasm to share his experiences with all of us, with his vast knowledge. He doesn't want to keep everything to himself. He wants to share it more and more, and wants to proliferate that knowledge more and more. Very soon, we're going to be having a book which is more of a summary of his shared experiences coming out very soon on the Indian scene. Subject of the day, I think it's been chosen very, very appropriately. I had started initiating this subject almost a year back, more than a year back. And I learned my lessons, or we all have learned our lessons from various places, but 2 instances which I will mention here, which are worth mentioning. One is the Western Express Highway in Mumbai. Those of you who've been frequent visitors to Mumbai, when you exit out of Mumbai airport, that's the Western Express Highway. You dare visit that during the monsoon season. Okay, there's a reverse flow from the sea in case of high tide. When there is incessant rain for more than 4 hours, the area entire gets flooded because water doesn't know where to go. There are no exits. So somebody came and let's have small drains. No, drains cannot take care of the surface water always. Drains get choked. Then somebody came with the idea, let's have some can have some hundreds of cusecs of water. Beyond that, the sumps also start flowing. And where will this water go? You have to pump it out. Your pumps will malfunction. So we were toying with an idea that is there a case in point now that the tunnel, in addition to being transport and hydro tunnels, tunnels are storage tunnels. Why can't the tunnels, in addition to sewage, can also be anti-flood tunnels to carry the flood water to an area where you can store it or throw it or release it wherever you want to do it. So today we're going to be talking about the structural and non-structural measures. Structural is what you can do with the structure. Okay, and non-structural is by public awareness and by public safety as to what all can you introduce to see that your population at large, your business at large, your activity, your life at large is not hampered. Closer home, those who are in NCR would have realized that every year, whenever there is a rainy season, Delhi, one of the ring roads or both the ring roads at times are very, very seriously affected. And you come to Gurgaon, which is a millennium city. What happens at every choke, starting from IFCO choke to every choke, it's inundated, 2 feet, 3 feet of water because there is no drainage. So drainage is a very, very important subject. We're going to touch upon it. And just a mention in the passing, an idea came to me yesterday and I flashed that idea to Professor Wagner for deliberations. May not be today, maybe subsequent exercise we will do, that now in the vicinity of our living areas, cities, we also have pockets which are the industrial areas. Normally, good areas are given for the institutions, residential areas, and other activities. And generally, the areas which are not good for agriculture, not good for living, are given to the industrial units. So they are generally low-lying. Okay. Now, as long as there were 1 or 2 or 3 industries, each one took their own care. Now that the industries are mushrooming up, you go to any industrial area in India, it's becoming a huge problem. What happens to the drainage during flooding season? And if the water table is high, you don't know what to do with it. Whoever has got a plot which is higher is safe. And if it's a low-lying area, your equipment gets bad. Your areas get inundated, and you don't know what to do. You can't even throw that water out. So we have to find some kind of underground storage, sumpage kind of a facility. But ultimately, that facility has to be connected with a major facility to be provided by the government of India. We're going to look at some of those solutions in a subsequent session. But very briefly, Professor, I have requested Professor Wagner so that this issue remains in your mind. And some of you can even deliberate about it in your own small organizations as to what do we do with it. It's a real life problem. Okay. And he's going to spend 2-3 minutes just as his very, very preliminary impressions as to what can be done about it. I'm not asking him for detailed study as of now. Subsequently will be done. Now, I think I've taken enough time for the introductions, but I thought this was necessary to set the stage for the speaker to take over. So now I request Professor Wagner, over to you, sir.
Thank you very much, General Suresh Sharma. I am very, very honored and very, very pleased to talk about flooding. As always, I'm very enthusiastic about my connection with Central Board of Irrigation and Power and Tunneling Association of India. But right now, I don't have my PowerPoint on the screen. Is there anything you can do about that? Because I think it is up to you.
Hello.
Hello.
Yes, sir. So you can just reshare your screen, sir. Again, share it, sir. Just click
Screen
on share.
share.
Yes, sir.
Okay. Okay.
Yes, sir. Again, slideshow from beginning.
Just a moment.
Yes, sir.
Okay.
Yeah, perfect, sir. Perfect.
Okay. So I just wanted to make a statement how much I feel enthusiastic about the connection, about the contact which I have with Central Board of Irrigation and with Tunneling Association of India. It really is inspiring me. It is more than inspiring. It's firing me up, and I really like it, and I'm very happy about that for sure. In particular, because General Sharma already mentioned that the book on usable grounds is in almost finishing stage now. I have been working on that for quite some time, and I'm very, very honored and pleased if through CBIP this book will be produced and published in India. Okay. So I think I can skip these slides because it just tells what General Sharma already said about me. Talking about urban flooding, we have to state that damages are caused by urban floods, and these floods are on the rise. It is therefore important to understand that the causes of and impacts on different types of flooding are analyzed. Urban floods in coastal area are a growing issue of concern for both developed and developing countries. And they cause damage to buildings, utility works, housing, household assets, income losses in industry and trade, losses of employment to daily earners or temporary workers, and interruption in transportation lines. So that was kind of an introductory note, and now I want to give you an overview of the content of today's online lecture, starting with some remarks on the largest city on our planet, also how much oil production is influencing climate change. We all talk about climate change since the Paris Agreement, which was in 2015 until 2021, when there was a big conference, almost 3 weeks in Glasgow in Scotland. Then I will talk about passengers and urban transport, I found a map of the cities which are in crisis in India, in crisis because of urban flooding and causes. Then I will go to one of the key experiences which I made here in Bangkok in the 2011 flood, which has affected, and I will talk about findings also of this flood to Thailand. And then I will raise the question whether the problem has been improved or not, and what we are doing in order to improve it. I will also talk about river basins for floods. Typical river basin is the Chao Phraya River, which is a river basin directed north-south until it reaches to the Bay of Siam. And then I will talk about a concept of flood relief tunnels, because the floods, you know, if water has no waterhead, there is no movement. But if there is a waterhead, there is a potential for gaining energy through hydropower stations. So I will talk about that flood relief tunnels and what can be done, and I will give you some examples also. And then I will talk about flooding today and flooding tomorrow, present and future, and what can be done about flood tunnel construction and what is important to follow when we do such tunnel construction, and how much the alignment is important and how we choose the alignment for such structures. Then I will talk in general about infrastructure as flood tunnels, and flood control in general is something which is an infrastructure, part of the infrastructure, and come up with some conclusions. Now, if we take a look to the largest city and to the urban agglomerations worldwide, we can see that we have extremely growing populations in urban areas, and number one in that respect is Tokyo with almost 40 million people, and then Delhi with some 25 million people, and Shanghai in China with 23 million people, Mexico City with 21 million, almost the same as Sao Paulo in Brazil. And then if we go to the population of Mumbai, we are also slightly over 21 million right now, like Osaka with 20 million, Beijing 20 million, New York with almost 19 million, and Cairo in Egypt with 18.5 million people. So these are the largest cities in the world, and also the largest areas with regard to growing urban population. So this climate change is essentially affected at about 25%, 23% of the climate change is caused by fossil fuels. And this slide shows you how much fossil fuels has increased in different areas of application like air and rail and marine and off-road and trucks and heavy trucks and light trucks and cars also. So this is in an overview of where we can see how much these consummation has been affected in an urban context in the United States from the transportation and consumption between 1970 and 1970 and 2035, which is an exaggeration, and we can go to the next slide. The next slide gives us an idea about different types of traffic in urban transport and passengers per hour related to a 3.5 meter wide lane in the city. And we can see that the suburban rail systems have increased most with heavy rail between 40 and 60,000 passengers per hour, with light rail and pedestrians and cyclists, and also mixed traffic. Quite a heavy portion of the passengers passenger per hour in our cities. Now we are in India, and we are talking about flood maps and flood crisis in India. And it gives this slide gives us a look at the few cities that are on the brink of a possible crisis and the problems that they are grappling with. We can see some of the Indian states with Rajasthan, Uttar Pradesh, Haryana, and so on to Andhra Pradesh in the south. And we can see also how much overloading of existing drainage systems and encroachment of vacant lands, slums, have an influence to the forecast and to the estimation of floods in India. And we definitively have to also understand what General Suresh Sharma said, that this is not a single place. It is a subject and a problem which is to be tackled on a much greater scale, and therefore there is definitely a need for more and deepening understanding and engineering also, and therefore this idea to go deeper into that and make another presentation is a really a very good idea. Now, what are the causes of urban floods? Urban floods have direct factors as causes and indirect factors, and part of the direct factors are climate change, change in weather pattern, and also heavy rainfall. But also urbanization is a direct factor, with developments encroaching floodplains and causing loss of natural storage, continued development and redevelopment to higher density land uses, and also increased impervious areas such as roads, roofs, paving, asphalt, due to increasing development densities, which means more runoff. And then we have indirect factors with improper, inadequate drainage systems and on-road vehicle parking, which is another obstacle. Then it's the attitude of the people and the improper or no waste management, which has a kind of also indirect factor causing urban floods. So when we go to Bangkok flooding in 2011, Bangkok has been hit heavily by heavy rain. And the question is whether Bangkok will see major floods again or not. Despite horrible experiences in 2011, the city and country remains vulnerable to floods. So the question is also, who is to blame for that? Is it the people's garbage clogging drainage system? We know that this is a big problem. Is it the inefficiency of administrations? Giant tunnels. Giant tunnels are drainage tunnels which are in construction or in just preparation for construction. Some of them are in construction, which offer some sort of reservoir in the urban part of Bangkok, similar to what we have seen in Tokyo or what we have seen in Chicago also, where the cities have been, the city administrations have been providing underground reservoirs and then dealing with these reservoirs. And the management of storage systems in the reservoirs. Is this management responsible, and is this management going to be blamed? This shows the actual situation in Bangkok in 2011 with urban flooding, and you can see here that except the bridges where people have been putting their cars to park on the bridges, because definitively Bangkok was not only flooded, but Bangkok was sinking also because of the flood. So this was a big problem, and this big problem still is not sufficiently tackled. So the question is, has the problem improved in the meantime? If we look to the cost of floods in 2011, it has been exceeding $47 billion. And the question also is, why would the 2011 flood not be repeated in 2022, during this year? And what is the response of the Royal Irrigation Department? The Royal Irrigation Department is the department which handles these problems and is dealing actually with all irrigation problems in Thailand. Means the whole country is under control of the so-called RID, Royal Irrigation Department. So what happens when the large-scale reservoirs are full? What happens if they are not full? And the water runoff in Nakhon Sawan, 43% less in 2021 than in 2011. And in 2021, also the accumulated rainfall has been less than in 2011. So this gives the Royal Irrigation Department some comfortable feeling that telling the population, don't worry, we are not having this serious problem right now because of the runoff of the Nakhon Sawan River, and also because less rainfall. So the problem is not that big, but it is kind of a policy where we know that there is a bird in the desert which always, when it comes to some critical situation, then it puts the head into the sand, so it doesn't want to see what is happening around that. So this is the policy of the bird south. So if we go to make a flood view and analysis of the flood view, we have to state that there is a hardship and damage during the prolonged and widespread deluge, followed by seemingly long-term and sustainable grand elaborated plans proposals. There are various views of the problem. First of all, there is lesser natural disaster right now than it has been. It is more a case of mismanaged water resources. Another view is maybe that numerous prescriptions by what should be done exist, but are not followed even, but anyway, exist on paper. Then there are committees to study the solutions and developing recommendations for the various aspects of the problems. Then there are also ambitious ideas, for instance, new floodways, dredging channels, and so on. And there are streaming laws and agencies for water management, which are involved and which are responsible for floods. So how do we protect against flooding? In this picture, you can see an activist of the community in the flooded Chatuchak district in Bangkok, which has set up a large barrier of sandbags along with pumps in an attempt to protect the Monban Kret Kyu housing development from being inundated in 2011. So this is something which we all know. It cannot be considered as a solid and robust solution from the point of view of the engineering, but it is something which has happened, and we still know that people are using this sandbag. I wouldn't call it technology, but it's a sandbag nuisance that gives an immediate protection. We have seen last year in Germany also huge floods in the summertime, and even in highly developed Germany, sandbags have been the immediate assistance or immediate help to get a little bit of an improvement of the problem. There are attempts to establish a floodwater research institute, which should become an authority to manage water resources, embedded in some 50 different laws and involving 30 state agencies and a number of 7 ministries. None of the laws authorizes to divert water for different usage. None deals really with flood management, even if it is called a Floodwater Institute. And there's a plan to set up a water ministry to consolidate all agencies, but this plan never got off the ground. So still, it is what is sometimes called a paper tiger. There are other views of the problem, in particular doubts about the efficiency of the giant drainage tunnels, which are those projects which are in construction right now here in Thailand. Then there are views also with regard to a proper flood warning system. Now, this flood warning system may something which is going to be improved and maybe is going to give some real help in regard to the software development for flood warning systems. And with that regard also may help also to improve the flood warning installations, not only the systems, but also the installation. Another really hot potato is that Bangkok might be sinking underwater in 15 years. We know that we have different influences to consider, which is causing sinking of Bangkok. First of all, it is the extraction of groundwater for a city which is something like 15-16 million people in an area like a small Austrian province, and the extraction of the water is causing some sinking. At the same time, we know that definitively sea level is rising, and the rising sea levels is caused by melting ice of Greenland, melting ice in the Antarctica and the South Pole, and this sea level rise has something to do with climate change and global warming, and is also contributing to a sinking tendency of Bangkok. So 15 years may be a number to alarm and to trigger the authorities that flooding is coming. And then we have to look also into what endangered other countries are doing to control flooding and to stop sinking. And there are two very prominent examples. One is in the Netherlands, the reclamation of land from the sea, like it is also in Singapore, reclamation of land from the sea. And the other one is historically placed, beautiful city like Venice in Italy, which also has been endangered of sinking, and where after decades of planning, a system of locks has been installed. It's 90-95% complete right now. So if this system of locks is installed, then the lagoon of Venice will be saved. So how much is Bangkok sinking? Depends. My personal experience in the house where I am living is that during 10 years, the land has been sinking 10 centimeters. That means 1 centimeter per year, or 10 millimeter per year. Excuse me, 1 millimeter per year is 10 centimeters per decade. In 10 years, 10 centimeters. Okay. So Bangkok is in search for a long-term flood prevention system, and we will come to that point during the next slides. So this is a slide which shows the river basin of the Chao Phraya River, where Bangkok is in the southern part of the Chao Phraya River. The Chao Phraya River, which is comparable with the River Danube in Europe, or with the Ganga River in India. So Bangkok is actually in that dangerous situation of flooding caused by the river Chao Phraya. Bangkok has had several severe floods, and just to mention the most recent ones, there was a severe flood in 1942. That is almost 80 years ago. In 1983 and in 1995 also, all of these central Thailand has been flooded, in addition to 2011. When there is flooding, then there is also subsidence, and subsidence or settlement of structures must be controlled. So this land subsidence in Greater Bangkok is witnessed by widespread exploitation of groundwater extraction, leading to significant land subsidence and damaging of urban infrastructure. Another example of what you see here on the right side of this slide is the sinking of the roads, and lots of transportation infrastructure in Bangkok and in Thailand is all elevated, and these elevated viaducts are located and situated on deep piles. So these deep piles in the range of exceeding 25 meters, sometimes 30, 35 meter deep piles. Even these piles are keeping these viaducts in place, but the land, like you can see on this footpath here, the land adjacent to the deep pile foundations is subsiding. Measures such as banning the drilling of water wells together with licensing and charging for groundwater abstraction have been introduced, but could not really solve the problem in a lasting way. Again, Bangkok has been flooded in the Bangkok streets in 2011, in particular in central Bangkok. You can see here also what we have seen before. The bridges are full of cars. Traffic has been stopped. No traffic could happen anymore because all of these parking cars have been jamming the traffic and stopping the traffic. So the study on the causes did show that the behavior and flow pattern in Bangkok metropolitan area for the purpose of development of protection and management systems to control future flooding risk has been analyzed. However, evaluation of strength and weakness of existing flood protection and drainage system has been done, but it has not been sufficiently solved the problem. And the study of the flood effects and the performance of existing underground utilities and infrastructure has been also performed. Lots of studies have been produced, and that all contributes to the overall system, to the overall flood control policy developed so far. Now let's talk about a little bit about the groundwater nexus, about the connection of flooding and how this is to be seen in the context of the groundwater. The groundwater pricing mechanism, which has been introduced in Bangkok, is considered to be a success. So charges were slowly increased until 2003. After 2003, charges have been exponentially increased. additional charge for groundwater preservation has been introduced in 2004. And now the groundwater is more expensive than water from the piped public water. It is a combined pricing with developed for the public water, and it has been reduced from 2000 to 2005 from 2,700 million liters per day to 1,500 million liters per day. And the land subsidence has been reduced, significantly reduced. It has been worse before. And the groundwater preservation charge is considered to be an innovation, political innovation, and earmarked for research and groundwater conservation activities is in the so-called Groundwater Act. The groundwater level control, it's illustrated for the Bangkok area on the right side of the slide, where you can see the difficulties encountered in trying to control groundwater levels. The blue areas is the area where the groundwater levels all have been lowered. The question is how to find the right balance of tariffs to achieve a reduction in abstraction and extraction challenges, and the measures undertaken by the Bangkok municipality have resulted in positive outcomes, and similar measures could yield benefits elsewhere. So it has been used as an example for improving. There is a thread shown on this slide. If you look carefully in the middle of the slide, you can see the flow of the Chao Phraya River and the areas with high and with high level areas, which are the darker brown area, and with the lower levels, which are the more green areas in that particular slide. So basically what we can say is that the Bangkok area is an area which is the result of river sand and silt transportation. It's covering the whole basin of Bangkok. The bedrock is 300 meters deep. So everything above the bedrock is different layers of sand and silt and different permeabilities of these different layers. They're all interconnected with each other. And so the whole area is kind of having the groundwater level close to the surface, just a little bit different, few meters between different areas of the city. So how is the disaster spread? You can see here there are two arrows in the upper part of the slide. You can see Bang Sai and Wang Noi area, where in the center we have the Chao Phraya River, and we have another Ta Chi River on the left side of the stand. And we can see that this is how the disaster has been spread over in terms of the blue colored areas where inundating has happened in Don Muang Vipavadi area, where we have the old airport from Bangkok, and the Nonthaburi area, which is another inundating area on the left side. So Nonthaburi and Samut Prakan and Samut Sakon are those areas which have been heavily flooded during this flood 2011. The question is, what are the estimated losses from the flood in 2011? It has been an estimate which was done by Thammasat University, well-recognized university here in Thailand. It is estimated that the loss has reached up to 1 trillion of Thai baht, with a conservative cost estimate being between 400 and 600 billion. Now, how much is 600 billion? 600 billion baht is about 30 billion US dollars, just roughly 30 billion US dollars. 30 billion, yeah. So the National Economic and Social Development Board also has done an estimation of the flood, and this estimation was on the conservative side with about 300 billion Thai baht, or 300 billion Thai baht is 10 billion US dollars. But the World Bank also has done a cost estimate, and truly this World Bank cost estimate has been done by very experienced people, and they estimated more than Thammasat and more than the National Economic and Social Development Board. It estimated that the total loss was 1,200 billion Thai baht. Again, that is 60 billion US dollars. 60 billion US dollars. Now, flood relief tunnels are not a total as such, you know, is not a total innovation. There have been flood relief control concepts and risk control concepts in the past, and one of that is the Waller Creek Tunnel concept in the United States, which has been developed in a conceptual phase in California to better control the risk of flood, which can be defined as the combination of probability of the event and of its consequences. In all type of undertaking, there is the potential for events and consequences that constitute opportunities for benefit at the upside or threat to success at the downside. You can see the inlet and pond of the Waterloo Park, and then we have the main creek flowing to the lake down the 4th and 5th Street, and then reaching the outlet and lagoon at the Lady Bird Lake. And the total extension of that flood control concept is 5,600 feet in length, with an inclination of the slope of 0.5%. So this is enough to get the water, if the water is increasing and development a threat, then this would be okay to have this flood control tunnel type for the Waller Creek project in the United States. Now, I have my personal experience with the Boston Outfall Tunnel, which has been named as the cleaning of the dirtiest harbor in the world. And what you can see here is the metropolitan area. Excuse for the quality of this picture, but I hope you can see what it really is meant to be. We have maybe I can show you here. This is the intake shaft, which is about 100 meter deep. Sorry. And what we can see also is the two types of tunnels. I have been involved in the Outfall tunnel, which was a 10-mile or 16-kilometer long tunnel underneath the harbor of Boston. And at the end of the tunnel, we have the arrangement of so-called diffuser caps. And these diffuser caps, they discharge the water into the open ocean. And what you can see here is the depth of the tunnel and the principle. Please also take a look to the principle that the water is collected and runs down into the shaft, and then from the shaft 10 kilometers out into the ocean. At the end of the tunnel, we have the diffuser caps, and the diffuser caps which are then discharging the water from the tunnel into the ocean. So this is the concept of the Boston Outfall tunnel, shaft and tunnel combination. There is another concept which directly relates to the Boston Outfall tunnel, which is the Frederick water distribution concept. It is a concept located, actually implemented at the Lake Michigan in Chicago. And you can see here the water enters through the filtration plant into the filtration system. And in the filtration system, then it is distributed into the infrastructure in different different parts of the city. So there is the water distribution concept 1, where the pump floods the water through the outfall tunnels. It is using diffuser caps for distribution into the sea or into the city, and it keeps Bangkok dry during floods in the future. And then we have the second water distribution concept, where we refill the aquifers later via horizontal filter pipes and feed the aquifers at a lower elevation. And in that regard, the result will be that the sinking of Bangkok with up to 3.5 centimeters per year will be stopped. So that is this water distribution concept, which is implemented at the Lake Michigan in Chicago. Now, a flood relief tunnel is a win-win infrastructure for flood prevention. It offers hydro energy production, upgrading infrastructures in development of coastal areas. It also makes the water flow towards the same level in two pipes, as there are differences in specific weights. We have the fresh water and we have the salt water, and there is a difference in the specific weight, where the fresh water always wants to go on top of the salt water because of the lesser weight. And coastal areas are all prone to floods, which is feasible to make use of floods, fresh water from the rivers. If there is a waterhead and if the water flows, there is a waterhead, and this is a potential for energy gaining, for energy production. The fresh water is directed into the sea, which is salt water, from the intake shaft through the inclined tunnel. You can see this scheme, which is the connection between Ayutthaya, the former capital of Thailand, and Bangkok. And there is a shaft in the area of Ayutthaya. The depth of the shaft is estimated at about 155 meters. And there is a hydropower station producing 800 megawatts per year before, due to the fact that the water is running uphill, and it has an outfall tunnel with a flood gate or with diffuser caps, as we have seen in Boston Harbor Tunnel, and the hydropower station in the coastal area of Bangkok. Now, the flood relief tunnel concept is, as it has been done for the Boston Outfall Tunnel. The picture shows the lowering of one of the vehicles which have been used in the tunnel. It was a big tunnel with 8.5 meter diameter, inner diameter, precast concrete segmental lines tunnel. Geology has been almost uniform soft ground, clays and sands, comparable with the geotechnical conditions in the underground of Bangkok. Groundwater is near the surface. Location is north of Ayutthaya at the confluence of 3 rivers. Diameter of the shaft up to 25 meters and the depth about 150 meters. So these are preliminary conceptual design phase. The outfall tunnel has intermediate shafts. The length could be about 100 kilometers instead of Boston had 16 kilometers. The length of the outfall tunnel for Bangkok would be much longer. The diameter approximately 10 meter inner diameter. The slope is 1 by 1,000. The discharge approximately 7,000 cubic meters per second. That is the discharge of the maximum discharge of the Chao Phraya River. And the actual discharge of the Chao Phraya River is in the range of 2,500 cubic meters per second, with a waterhead of 150 meters, which is exactly the same as the depth of the intake shaft, and the hydraulic data, which needs some more evaluation and confirmation. The flood relief tunnel concept is a very simple concept. It is called also the KISS solution. Build the tunnels and pump the water into the tunnels. Build 2 water distribution systems, which we have seen water distribution system 1 and 2, and build the hydroelectric power plant between 800 and 1,600, 1,600 megawatt, which is quite a very big hydropower station, because it can use 150 meter of water head. The new concept is called Frederick, and it is able to solve Bangkok's 3 main problems. 3 main problems are the hydraulic problem, the geotechnical problem, and the financial problem. Thailand being the capital of Thailand, Bangkok being the capital of Thailand, would be saved from flooding within less than 5 years at costs of approximately $3 billion, with the hydropower generating revenues and with the return of investment in less than 10 years. So that is quite an attractive opportunity to not only get control over the flood and the risk of flooding, but also to get the invested money and the return of that money within reasonable times. So what are the issues of risk management of floods? First issue, of course, is the water resource management. Second issue is the river basin flood engineering and the management of that flood of the river basin. Third issue is the urban flood engineering management and the coastal flood engineering management and the flood protection engineering management, as well as the issue of flood prevention schemes and systems allotted to flood prevention schemes, the integrated flood disaster mitigation, the prevention of flood and the preparedness for floods, and the flood relief and the rehabilitation. So these are all risk management issues with regards to flood. For the metropolitan area of Bangkok, the flood control measures are managed by means of open channels right now, by means of shallow tunnel structures, but also by means of deep flood water tunnels and by means of multi-purpose infrastructure. And with that, I would like to touch the issue of Kuala Lumpur in Malaysia and their unique and innovative smart tunnel concept. So this slide also shows you preventive flood risk management, flood event management, and post-flood measurement. So all these management is in a cycle, it's in a cycle condition and has to be considered in a cycle. The salient features of a hydropower project on the Chao Phraya River hydroelectric power station would have a capacity of approximately 800 megawatt with revenues of 240 million per year estimated, with a return of investment within 10 years, and with financing which will be attractive both to the World Bank and to the International Finance Corporation, IFC, with the details, rough details of the investment for the tunnel. It will be approximately $1 billion, 1,000 million. For the shaft, about $50 million. For the powerhouse, about $250 million. For the equipment, it's estimated 200 million. So the total will be about $1.5 billion US, or 45 billion Thai baht. So we have to look also into the goals of the flood tunnels. The goals of the flood tunnel with respect to environment. With that respect, it drives the demand for infrastructure, such as demographic change and economic growth, and must be coupled with an appreciation of the goals that strives to achieve, such as providing access through efficient system performance, safety, equity, sustainability, and resilience, and the conditions that drive infrastructure supply, such as financial and energy resources, governance, institutional capacity, and innovation. So all these are goals under one roof, under the roof of flood tunnel implementation. So from the point of view of public ownership and management of infrastructure, we have to look at a different set of incentives than those that drive private sector innovation. These public sector incentives inhibit risk-taking and reward caution. So this is the public ownership or the responsibility of the public with regard to flood tunnel implementation. From the point of view of infrastructure, there are steady incremental gains in infrastructure design, construction, operation, and management, identified through applied research funded by public agencies to have provided great benefits to the public over the time. So these are actually benefits to the public, benefits which we get from the infrastructure implementation of flood tunnels, and gains for the environment. In such project, we have to make a so-called plausibility check. We cannot only say we do a fascinating project, we also want to know the plausibility. The plausibility has to be made with the initial documents. And these documents are passed on without checks. Any efforts are meaningless. So if we do not check, then there is no meaning. We have to check and to find out whether it is plausible or not. The amount of papers produced is no guarantee for the quality. We can produce a lot of papers, but plausibility is above all. The software application for recording only makes sense if recordings are checked for correctness and for plausibility. And the contractor and supervisor of a project for flood control has to take time and know how to make the necessary checks. So what we can see here is a project which is in difficult ground conditions, which is using conventional support system for the implementation of such a project, which is a project in Bangkok. So let's talk about the presence and future of flooding. Modern urban tunnels are challenged by the request to strengthen engineering capabilities using innovative technologies in project delivery and quality management. So innovation is the driver, and we still not only have to understand what innovations have been developed in the past and where we are today, but let me also state that the future is in need of innovation and further improvement, and that is only possible because of tunneling is the art of uncertainties. It's the art where we are challenged every time we have a new tunnel. There is no tunnel 2 times the same in the world. And where we have a field for innovation and for improvement. There is a future understanding and effective mitigating risks and hazards in underground works by all stakeholders, which requires professional planning of underground networks to enable and safeguard future expansion and extension of all infrastructure projects. So we all understand that in the Tunneling Association of India, and with that under the roof of the Central Board of Irrigation and Power, we have a new developing world every day, every year, because the expansion of the underground infrastructure is continuing and gives us a lot of ideas and a lot of incentives for improvements in the future and for challenges, for meeting challenges. How does the International Tunneling Association view flood tunnels? It is viewing flood tunnels from the point of view that underground networks and extension have a special emphasis on advantages provided by interactive communications with the International Tunneling and Underground Space Association. And the benefit is regardless the technology applied, whether we do it conventional technology, whether we do it mechanized technology, whether we do it hybrid technology, any tunnel contract of today is benefiting from carefully performed ground investigations. We have had a very interesting lecture on ground investigation, and which is part of the book which is going to be launched. I will talk about that a little later. Resulting in geotechnical baseline reports together with risk management plans, whilst recognized and supported by all project stakeholders. So that is the view of the International Tunneling Association, that all stakeholders are included. Now, risk management of floods. We have different types of risk management from resource water through the river basin origin, the urban flood, coastal flood, flood protection, prevention, disaster mitigation, prevention and preparedness, and flood relief and flood rehabilitation. So flood tunnel construction is basically to be seen from the point of view of analysis through data collection, through monitoring, until we finally come to the tunnel boring machine. And in this case, the slide shows you the case of a tunnel boring machine and what the tunnel boring machine parameters are. So we start different clients at real-time analysis and behavior, system behavior analysis. Then we go to the pro-construction database, where we look into ground and TBM parameter and geotechnical monitoring, building the basis on excavation and data collection and data transfer via internet or immediate analysis. So from the point of view of ground, we have expected ground conditions in the tender document, which actually include the geotechnical baseline report. Then we have, after the expected ground, what is the actually encountered ground? What is the ground strength? What is the permeability, the groundwater inflow? What are the fault zones, fracturing, cast, and this type of information which goes directly from the ground. And then we have to look into the TBM parameter. What are the operational target values in comparison with the actual values? For instance, what is the face pressure? What is the conditioning of the face pressure? And then we go into geotechnical monitoring, where we find out about the differences between the tender documents and the actual conditions. In an urban construction site installation, we always have to look into 3 steps. First step is the definition of the project risk and the mitigation measures. And the second step is the analysis of the ground behavior of the system. And the third step is the real-time analysis by using enlarged cybernetic systems. So this is the process control for flood control in an urban construction site. We have different design phases. We have the project preparation phase, and we have the general design phase, where the project preparation is arguing and document motivation for the project, is defining and document objectives of the project, establishing a reliable base for the follow-up steps. And then the general design is to apply the so-called modular structure of the design, then to adapt the flexible approach for different project types. For instance, for a new railway line, what is the railway station? What is the upgrade of the existing infrastructure? So there are different approaches and it needs flexibility. And also to specify the process tailored to specific requirements of the individual projects. So the general design includes feasibility study, conceptual design, then preliminary design, study of alternatives, and the preparation for the permit application to start finally with the construction. Far-sighted design is a very important one, and what we can see here is a cross-section, schematic cross-section of a tunnel which includes a stormwater tunnel and a two-deck roadway tunnel. So this is a far-sighted design because a feedback to previous phase required as if solution is unacceptable. The legal requirements, if they are not applicable, then it will damage the project. The success factors, however, are a broad, holistic approach to be applied and the relevant critical aspects focused on, and the coordination of the specifications for the data collection and for the requirements for decision making. This is again Kuala Lumpur's smart tunnel, and it has 3 modes, where we have mode number 1, if there is no storm condition, and on both decks of the tunnel we have traffic. Then we have the mode with most storms, which happens 7 to 10 times a year, where we have the tunnel decks in both directions with the traffic, but underneath we have the ground, we have the storm water. And then we have the major storms, which are annual events in mode number 3, where we have completely filled the tunnel with water, and where we have from the intake to the clong at the lower part of the tunnel, everything is full with water. This goes back to the feasibility study and the conceptual design. It has been addressing international topics. It also has been discussing alternatives. It has been evaluating requirements from the point of view of what capacity do we need, what is the traffic load, and what is the water load also. Then it has to define the system layout with the track configuration, the configuration of the junctions, intake and outtake, entrance and exit, and so on. And then it has to address key operational issues. All this is a comprehensive approach for the design. This choice of alignment is something which is very, very important and has to be done every time we have a tunnel. So we have to develop alternatives and then evaluate the alternatives against the project goals and come up with the best solution. Compare the alternatives in a multidisciplinary approach and then come up with the selection of the best solution. This slide shows you different types of depths under a river, where the depth below or under a lake, the depth below the surface between 45 and 50 meters would allow to look into a tunnel technology which is known as the immersed tube tunnel. Then if we go deeper with regard to 85 to 90 meters under the superficial sediments, we may come up with, instead of immersed tube, mixed shield TBMs. And if we go further and further deep, 150 to 180 meters, where we have soil conditions like morass, then maybe an open shield TBM may be the best solution. I have been studying that for the Gibraltar tunnel, which connects Africa with Europe, in connecting Spain with Morocco. And I have done this type of alternative studies, which still is not finished yet. There are some agreements, but that is another subject which I would like. Sometimes we have another opportunity to talk about mega projects in the world. And then I will talk about Gibraltar tunnels, about Bering Strait tunnels, about Nusantara tunnels in Indonesia, and about all these tunnels, which today are engineering dreams, but some of them became reality, and therefore we are encouraged to look into such mega projects, also into such mega projects which are connecting not only countries, but also continents. So we have to decide about details, and after we have done some alternative alignment studies, we come up to the preliminary design, and in the preliminary design, we define technical features, for instance, for a rail project in much more detail. And we develop secondary structures and protective measures, which are following, consequently following infrastructure projects. And then we execute project optimization in a process to maximize the benefits and to minimize the effects on the environment. For instance, there is a project where I have been involved in Nepal close to India. The 31 billion rupee Melamchi project took more than 2 decades to start distributing water to Kathmandu, the capital of Nepal. The flood has now pushed back this project's development. According to the project chief, no one had imagined there would be a flood of this scale. It's an unimaginable disaster, which Kumar Shrestha said about this. And in the picture, you can see what happened last year, only last year, that this project has been heavily affected by the flood in the middle of the year. So we have to decide on details in order to make structures, even secondary structure, flood protected. We have to define criteria and technology and environmental and cost from different points of view. For the decision, we have to focus on following aspects. We have to focus on technical aspects, which we have to separately address from environmental impact, where we have a broad multidisciplinary approach structured according to environmental disciplines. And the cost issue, which is a challenge due to lack of information and numerous risky uncertainties. So altogether, it's making the decision tools for traffic and transport, technology, for humans, for environment, and for the risk of cost. For the risk of cost, we want to understand the controllability of cost. We have a maximum of controllability of cost at the beginning when we do the route selection. And then if we go into the pre-design phase, then the controllability declines. Then we come into the phase of permission. It further declines in the direction of the detailed design, and finally in construction. We have a relatively least controllability of the cost. Challenges for cost estimates is very much in the early design phase. It is incomplete and project knowledge is not complete. There are uncertainties, a high level of uncertainties in the basic data for construction cost estimate, and for specific cost estimate, we have another additional approach which is required, and then for the application of adds on basic costs at several levels of cost estimate process. So all this is to be seen in regard to the development of the project. We have a risk controllability also. Reducing the risk then involves a set of measures contributing individually to risk reduction. What is helping most at this stage is a risk management plan. Upon adopting the measures, there might remain a residual risk always, and we should keep that in mind, that as long as the project is in construction, nothing is final. The flood risk management requires the holistic development of a long-term strategy, balancing current needs with future sustainability. An integrated strategy usually requires the use of both structural and non-structural solutions. So with that regard, we always have to look into the components, and we have to recognize the existing risks and likely future changes, which is crucial. Now, infrastructure consists of investment, innovation in many cases, consequences, and side effects. The public investment in research and human capital development has yielded many benefits and has never been as important as it is today. But whether and how it can be sustained remain in many cases open question. The remarkable degree of innovation in infrastructure and efforts to meet the great challenges of disruptive technological changes and climate change are resulting in natural experiments. So therefore, I call it always, every project, in particular flood control projects, are unique projects. Many of the consequences of continued innovation and automation of infrastructure depend heavily on how people will respond and adapt to these changes, which is not always predictable. Nowadays, we have more and more democratic developments and democratic liberalizations in our global village, let's call it our global village. And therefore, because of the democracy and the people which are which are allowed or accepted when they go on the street for demonstrations, there are unpredictable conditions in all innovation and automation of infrastructure. Yet, as important as human behavior is to understanding infrastructure and its side effects, however, only a small share of infrastructure data gathering and research and development funding addresses human behavior. So we have to still collect more data on understanding in regard to understanding infrastructure and side effects of infrastructure in order to get, let's call it robust design and robust projects. In summary, with regard to urban floods and flood tunnels, like other infrastructure projects, they have been plagued by cost and time over that deviate significantly from their value. The problems might be caused by administrative issues, by geological, geotechnical investigations, maybe by not enough engineering, poor engineering, and inefficient design. A flood infrastructure is requiring a high safety standard and is being essential for urban area networks. Flood tunnels, when compared with other infrastructures, they will have a high degree of safety and strengthening the resilience and sustainability of a project, of a flood project. To support the planning of operators from the safety point of view, a comprehensive risk assessment will always be used. Risk assessment in tunnel engineering shall be derived to ensure high safety levels when implementing changes in existing infrastructures. A simple and effective method of risk allocation in construction contracts to better control risk must include a geotechnical baseline report in contract documents in order to allocate the risk. The geotechnical baseline report is a contract tool for owners and contractors to provide the ability to define the level of geotechnical risk and financial consequences. In addition, there are ITA guidelines for the preparation of geotechnical baseline reports and considerable international experience. In conclusion, the demand for proper developed flood tunnels has been continuously growing. Intensification of networks shall provide better communication between regions and sometimes even countries and continents, with alignments corresponding to the demand of shortening operation times in response to sustainable and resilient requirements. Conventional tunneling method, as well as mechanized tunneling, TBM tunneling, are well suited for flood tunnels in increasing difficult, complex, and changing geological and geotechnical and contractual conditions. Innovative concept like the one which I did explain with the Frederick, the flood relief tunnel concept, are required to challenge sea level rise and climate change and subsidence. The main purpose remains minimizing overall construction time and cost, minimizing cost by selecting best suitable advanced flood tunnel contract conditions based on FIDIC Emerald book, the new FIDIC book, which was launched in 2019, WTC in Naples. Optimum driving cross-section, driving and aligning and lining methods during design and construction. And from that point of view, I'm just indicating one very brief picture with regard to flooding of low urban areas using underground or geotechnical measures. And what you can see here is something which has been used in the Netherlands with the water on the one side, the open water, the sea, or a lake, like in the Netherlands, the Zuiderzee, and the drainage ditch on the opposite side, and in between, the embankment body, which is fill material and embankment foundation based on the original. But this is only one thing. If we go into further details of protecting urban areas from flooding, then a lot of other measures may also be relevant in this context. But it was just a short notice which I have received. And I think it is very, very worthwhile, and it's very interesting to follow up this. With that, maybe I have exceeded my time already. Thank you for your attention, and let me answer all of your questions either right now or whenever you would like to do it in writing, just through Tunneling Association of India. I will be responding. Thank you very much. Thank you.
Thank you, Professor Wagner. Now, all the audience, ladies and gentlemen, should you have any pressing questions, you may like to ask now. Or should you want to reserve your question and ask through a mail, you are most welcome. Now, before you decide about your questions, I have two observations. Professor Wagner has covered a lot of ground, including the social and environmental aspects. And he's drawn his examples primarily from where he's stationed now, that is Bangkok. He's also given some examples from US and also the smart multi-purpose tunnel from Kuala Lumpur. Now, what essentially comes out is that yes, tunneling is an effective solution in the urban environment to avoid flooding. And in that, what he has suggested is that whatever methodology you use, whether you have a shallow tunnel or a deep tunnel, you have to have shafts, multiple shafts, and preferably a deep tunnel running at a gradient with the outflow, the water outflow, either getting discharged into a lake or a water body or into the sea. The only trouble with sea is the negative for water flow. So you will have to have some kind of sluice valve gates which can control the inflow of water from the seaside into the shore. There have been problems there also, but tunneling is an effective solution. It is expensive, but it is ultimately something which we will all have to resort to. And you can see now worldwide there is a great demand. He's also shown us an example from Kuala Lumpur. There's a smart tunnel where if the water gets too much filled up into those mini tunnels, those tunnels through their sump will open up into the main tunnel where the traffic shall be stopped and the tunnel can be filled up with that water for a limited period of time till the water is drained out. That is only in case of an emergency. Something like that can also be worked out. Flood relief tunnels he is already mentioned. So this is what we thought, probably it is the thought-provoking. It is yet to catch up in India. Why I mentioned and why we chose this subject is that we are all connected with the underworld, with the underground space. Now, underground space is not limited to metros. It's not limited to transportation tunnels. It is not limited to caverns. It has got multiple usages. And in the urban setting, today we have no option that for the flood or the flood prone areas and for the water supply and for the sewerage, you will have to go underground. We are going, but maybe the pace of work has to pick up. So that is one. Now, second is I had given him a question, although he just mentioned that in passing, we would expect a much bigger discussion with him at a subsequent date. That is regarding now our industrial complexes are getting filled up, are getting choked. There is no drainage planned. Too late now to plan a drainage. Can something be done about it? How do we go advising the agencies and the authorities to do it? He's shown us something like, okay, for example, from Netherlands, we know that, okay, there's a different state. That is, you are on the seaside, you build an embankment, and then next to the embankment, you have a small little ditch. Well, that is one way of doing it, but can you, that's not what we are looking for. We are looking for that there are industrial plots, 5 acres, 10 acres, 20, 30, 40 acres, each one having own internal drainage, but nobody knows where to connect it. So obviously there has to be a central shaft. Can we go underground? Because overground, there is no space left now. Can we go underground now, where the government can sponsor a project that, okay, the underground tunnel can come up, in 1 or 2 tunnels can come up, which can drain the flood water out of those industrial areas, not the industrial effluents. I'm talking of the flood water drains. So maybe we will deliberate about that issue subsequently and get our answers. Till then, anybody else having any question, please shoot. We still have time.
Well, thank you very much, General Sureshama. I think your observations are very, very important. And I just would like to mention that the problem which Bangkok has been facing, and many other cities, because I'm in contact with Shanghai, I have been in contact with New York also, with the different floods which happened there. And most of the coastal cities in the world have the same problem, that flood is a threat. And when we think about the threat, we like to feel comfortable that it's not going to happen next year or in 5 years. If it happens in 10 years or so, then we can still have a good sleep right now. But the fact is that, and I wanted to highlight that on the example of Bangkok, that the billions of dollars which have been caused, the damage, the damage in different ways, estimated from the university and from the local administration and from the World Bank, all different. The most expensive, or let's say the highest figure of the damage, was from the World Bank, with $1.2 billion of damages. If you think about the investment for tunnels, and you think about not only what I have been pointing out from the point of view of life cycle cost and so on, but from the point of view of investment and investment into the infrastructure, compared if you do not invest and you wait for the damage from the disaster, then we have a psychological problem because people like to push away the threat and said, it's not so bad. It's really not so bad, but it can be so bad,
Yes.
So the subject is that we have to be serious, and we have to also convince the public, the people and the media, that underground construction is not expensive, because we always think about that the expense, the cost which we have is a fracture of the cost of what the disaster is causing. So that is the point. And if we look from that point of view, then we are much more open to use robust engineering solutions and use the underground space, which basically is almost unlimited. You know, we like to be not too deep, yes, but the underground space is there. The crust of the earth is quite thin. You know, we have seen the outbreak of the volcano in the Tonga Islands. Okay, so we see that the crust is quite thin. So we can do a lot of good things, and I highly appreciate your sharp view of what industrial complexes are doing. They do for their own. They try to minimize the cost for their own project, but they don't think about beyond the fence. That there is a neighboring industry, and there is other neighborhoods, residential areas, and so on. So all this together is to be taken into consideration when we think about the need or the investment of a flood protection infrastructure.
That's very right, that the cost of damage caused by the floods is much more than the cost of investment that goes into the infrastructure. This is
Right.
It's not really a dilemma now, it's very clear. This is something which the governments have to be alive, and the society also has to take it very seriously. That point is absolutely well taken. Well, if there are no questions now, we would like to conclude here with a big thank you to Professor Wagner once again for covering a subject which so far, we, the tunneling community, has not really very seriously touched it, but this is an emerging field. And as we go along, we must see and open up the newer and newer fields in the realms of underground space. So thank you once again, Dr. Wagner, for a very,
thank you very much. Thank you.
Very, I would say, versatile and a very, across the board kind of a presentation. Thank you. And thank you, ladies and gentlemen, for being patient audience. Yeah, I can see one question here. It's appearing on the chat. Okay, that's thank you. Okay, there's the thank you note. Okay, not a question really, but notwithstanding that, especially to my young friends from the tunneling world, this is an emerging field. Maybe not so much in our lifetime, but in your lifetime, you'll see when we talk about the resilience cities, the future cities, you will have to build in these factors. That is your floods, your drainage, your sewage, all that underground. You have no space left in the cities now. And I touched upon a new subject now because somebody had given me a problem to give them a solution, although I have given them some thoughts that I had on the subject. That is, the industrial complex is now getting clogged. And there again, just to share what Dr. Wagner said, that one flood, where the flood water gets into the area of the factory and spoils their machinery, this is very corrosive. The sensitive machinery, if it is directly affected by the seawater or by the flood waters, is ruined forever. You can't afford that. You can't afford that. So even if it amounts to a couple of $1 billion or $1 million at the government level to invest into this infrastructure, it's well worth it. And this is the time to do it now. Thank you.
Thank you very much.
Bye-bye. Till we see you next time. Thank you.
Thank you.
Who else there? Thank you, Patelji, and thank you, Kalpana.
Thank you, sir.
Thank you, sir. Thank you very much.
Bye-bye.
Thank you very much. Thank you. Bye-bye.